For question 11 on the periodic trends, we're asked the following question. Of the elements boron, magnesium, nitrogen, and phosphorus, which has the smallest atom? And so we want to find those on the periodic table. I've got boron, got magnesium, nitrogen, and phosphorus. And so what happens as we move across the periodic table, atomic radius decreases as we move left to right. But as we move down the periodic table, atomic radius increases. So our atomic radius increases down the periodic table, and it also increases to the left on the periodic table. So we would expect to find the largest atomic radius way down here. And so in this case, we're looking for the smallest atomic radius. So the smallest atomic radius in this case, we're going to look for the element that's farthest in the upper right-hand corner, so something up here. And in that case, I would say that would make it nitrogen. Nitrogen is farther to the right than boron, so it's going to be smaller than boron. And it's also farther up in the periodic table than phosphorus, so it's going to be smaller than phosphorus as well. Of the ions chloride, potassium, and sulfide, which is the largest? So again, we want to find those on the periodic table. Here's potassium, here's chloride, and here's sulfide. When an atom loses an electron, it actually gets smaller because our electrons, right, they occupy space and they help determine the atomic radius. As I lose an electron, that space is now empty and the radius would get smaller. However, anions are larger than the parent atom. Because as you put extra electron density in there, you're going to increase electron-electron repulsion, and that's going to increase the size of the electron cloud. The more electrons we place in that electron cloud, the larger the ionic radius will become. And that's going to make sulfide larger than chloride. Potassium we don't have to consider because as it loses an electron, it's going to be the smallest ionic radius present. Reactivity is also tied to the atomic radius of an atom. And so in the next question, we're asked of the elements lithium, sodium, potassium, which one is most reactive? And our reactivity increases as we go down a group. And we saw that when we added lithium to water, it reacted a little bit. Sodium to water, it reacted a little bit more. Potassium in water, it exploded, caught on fire. So that reactivity increases as we go down a group because our atomic radius also increases, which means these outer electrons are farther from the nucleus, they're easier to remove, and that makes these atoms more reactive. So of those three, lithium, sodium, and potassium, potassium is the farthest down the list, and that would make potassium the most reactive of the elements listed. The next question, the first 8 ionization energies of a main group 4 element are shown in the graph. Which element is it? So main group 4 would place us in the 4th row of the periodic table. So we're looking for an element somewhere in this row of the periodic table. Next, we want to take a look at the ionization energies for this. For this question, the choices are gallium, germanium, arsenic, selenium, and bromine. And to answer this question, we have to look at the ionization energies. The ionization energy is the energy required to remove the outermost electron. Each successive ionization increases in energy, with the biggest jump in ionization coming when you're trying to remove a core electron. And so if you look at these ionizations, we see a small increase, a small increase, a small increase, and then between the 4th and the 5th ionization, the ionization energy almost doubles, which tells you between the 4th and the 5th, there's a big change in the energy associated with that electron. So if we look at the elements listed, we're looking for an element that has 4 valence electrons, because this large jump in energy here means here's my 4 valence electrons. I've lost those 4 valence electrons. Now I'm trying to take a core electron away. And so this can't be bromine. Bromine has 7 valence electrons. Selenium has 6 valence electrons. Arsenic, if we look at arsenic in the periodic table, it's group 5. It's got 5 valence electrons. The only atom that has 4 valence electrons would be germanium right here in the 4th group. So it's got 4 valence electrons. Hence, we see this big jump in energy, almost a doubling of the energy between the 4th ionization, removing the last valence electron, and the 5th ionization, trying to remove a core electron. So I would go with germanium for this last question.